Good evening everyone, welcome back to our channel. So today as all my videos I am going to particularly focus on the NCERT level of the topic cardiac cycle, and it is again part of your CBSE curriculum and a part of your chapter blood and its circulation, which is under the human physiology unit. So you can go ahead and read it after watching our video. So today we are going to study about the cardiac cycle. What happens is that the whole circulation part, as we all know, heart is the pumping organ of the body and it has to pump regularly without fail. So this is all in a cycle because blood comes to the body, blood comes to the heart, it goes again to the body, it goes to the lungs, again from the lungs it comes to the heart, then again I have already explained in double circulation, the blood comes to the heart 2 times and the heart without any fail keeps on pumping it back to the respective organs. So how it does that is through the cardiac cycle. So, to understand how heart meets our body's expectation of the circulation, we have to understand the pumping mechanism of the heart. So, for that, we have to understand that mainly there are, as we know, there are 4 chambers of the heart: right atrium, left atrium, right ventricle, and the left ventricle. So, basically 2 atrium and the 2 ventricles. So, the right part is responsible for the circulation of the deoxygenated blood, while the left part is responsible for the circulation of the oxygenated blood. So what is happening here is that the these chambers contract and relax alternatively so as to send in the pump in the blood and as well as receive the blood from the body and from the other organs as well. So what is happening here is systole means contraction and diastole means relaxation. So ventricular, just like this, ventricular systole means when the ventricles contract. Atrial systole means the when the atria contract, and there is an atrial diastole and a ventricular diastole also, but the ventricular diastole as well, but I have written it as joint diastole because most of the diastole of both the chambers coincides. Okay, so that is why we call it as a joint diastole. When you go on later and read it in higher textbooks, these systoles and diastoles are further divided into different phases like rapid filling or rapid emptying, that at this level you do not need to know. So what you need to know is the basics of the systole and the diastole according to your NCERT book. So a cardiac cycle, as I have depicted in the circle, is 0.8 seconds. Okay, this is the time and it is all in seconds. Okay, so again, since it's a circle, it doesn't matter where you start from. I am going to start from atrial systole. So what is happening is that first of all you have to understand what all is coming in the atrium. Okay, so this which brings in the blood from the body is the vena cava. Okay, so into the right atrium is the deoxygenated blood which is from the whole body and poured into the right atrium to the vena cava. Whereas if we see the left atrium, the blood is by this vessel here is the pulmonary vein, which is bringing the oxygenated blood from the lungs into the left atrium. So right now, what is in the atria? The right atrium contains the deoxygenated blood from the vena cava and the left atria contains the oxygenated blood from the pulmonary vein. Okay, it is bifurcated here, both the pulmonary vein and the pulmonary artery, because it does bifurcate in real life because there are 2 lungs. Okay, so now the atrial systole is the atrial contraction. Okay, so atrial systole in general lasts for about 0.1 seconds. When this whole blood is by filling there is a sinoatrial node right here which generates a potential which leads to the systole of these atria. These atria contracts as a whole machine, as they contract together. The atria contract together, and that potential, why do they contract? Because there is an action potential which is generated by the SA node. SA node is present right here, where have they shown in the right atrium on the posterior wall towards upside. Basically here is the SA node, which is the generator of the action potential inside for the heart. So this is the pacemaker. Okay. Here after SA node has generated the potential, the atria contract, and as a result what happens is the blood goes to the respective ventricles. Here the walls open, these are atrioventricular walls, and this is the interatrial valve and this is the interventricular valve. So the valve opens, atrioventricular walls open. Why? Because the pressure in the atria is more. So you have to understand that whole of the flow of the blood is according to the pressure gradient. Wherever there is higher pressure, the blood will move on from the higher pressure to the lower pressure, and the backflow of the blood will be prevented by the valves. So here, since right atria is contracted, contraction means there is more pressure generated in the area as compared to the ventricles, which are at this point in the relaxation phase. So as I have shown, this is the atrial systole. So as you can see, while the atria is contracting here, the ventricular diastole is continuing. That means there is no pressure, there is a low pressure in the ventricles as compared to the atria. So naturally the blood flows from higher pressure to lower pressure, that is from the atria to the ventricle. So now this is the end of the atrial systole. After this point, after the blood goes to the ventricle, about 30% of the blood goes to the ventricle by the atrial systole. That is why you have to remember this point, that only the 30% of the blood goes to the ventricle when atria contract. That means 70% of the blood from the atria to the ventricle goes directly because of the pressure which is by the vessels itself. So 70% of the blood goes to the ventricle, that is ventricular filling takes place without the atrial contraction. That is, even if the atrial contraction fails to happen, 70% of the blood will go to the ventricles no matter what. So now this is the atrial systole. Now what is happening is that the SA node gives in the potential to the AV node, which is the atrioventricular node, which is basically potentiating the potential, which is action potential, which is coming from the SA node, and sending it to the bundle of his, which is again sending it to the Purkinje fibers. So what is happening is that this potential is basically spreading all throughout the cardiac muscles. Okay, so that is why all the cardiac muscles, so that they can contract evenly together at proper intervals, so that there is no obstruction of the flow of the blood due to the irregular contraction. Though there are disorders where there is conduction disorders, because of that which the cardiac muscles cannot contract in unison, they cannot contract at the proper time at which they are supposed to contract, and because of that there is a disruption in the cardiac cycle. Again, about these disorders you will learn in your higher standards. So here we are, blood is in the right ventricle, and we are here where the Purkinje fibers are taking the action potential to the ventricular walls, muscles, ventricular cardiac muscles, the walls which contain the ventricular cardiac muscles. So now it is the chance of the ventricles to contract. Now as soon as the atria, you have to understand that we are basically learning everything in slow motion, but there is not that much time, there is not that much delay. Okay, everything is basically happening very rapidly, very fast, because it is even less than 1 second. So as soon as the atrial systole ends, the ventricular systole starts. Okay, so now the ventricles are contracting as a whole. Now when the ventricles are contracting, the pressure inside the ventricles increase. The pressure increases as compared to the vessels in which it has to send in the blood. So namely these vessels here, this is the pulmonary artery which is taking the deoxygenated blood from the right ventricle, and here is the this is the aorta which is taking the oxygenated blood from the left ventricle. So now this has semilunar walls. Okay, so as the ventricle contracts, the pressure inside the ventricle increases. Remember, the pressure of the left ventricle increases more than that of the right ventricle, and also the wall of the left ventricle is thicker than that of the right ventricle. And why is that? Because the right ventricle has to pump in the blood only to the hearts, which are situated right next to the heart, to the lungs, which is situated right next to the heart. Whereas the left ventricle has to circulate this blood to the whole of the body through the aorta. So there should be enough pressure which is generated that is enough to thrust this blood to the all of the body. Therefore, not only is the wall, not only is the musculature of the left ventricle more than that of the right ventricle, the pressure which is as a result, the pressure which is generated in the left ventricle is also more than that of the right ventricle. So normally when we are considering the pressure numerically to grade it, we take of the left ventricle only. So this due to the ventricle, this now the ventricle comes back to the ventricle systole. The AV node the potentiates all of the cardiac muscles, and the ventricle contract together to send in the blood to the respective great vessels. Now the walls, the atrioventricular walls, right side is the tricuspid wall and left side is the mitral wall or the bicuspid wall. Okay, so this valve prevents the backflow of the blood, okay, into the atria. So that is why even if there are disorders where there is regurgitation, okay, why? Because these walls fail to close, fail to prevent the backflow of the blood, for which they naturally are present. They fail to do that, and because of that, because of the pressure, what does is that part of the blood goes back into the atria as well only. So when the part of the blood goes back to the atria, the blood which is supposed to go to the other parts of the body as well as the lungs decreases, and because of that, the cardiac output decreases. So these valves play a very important role in preventing the backflow of the blood from the ventricles to the atria. While the semilunar valves, which is in the vessel, they open up, and because of the increase in the pressure in the ventricles as compared to these vessels, the blood flows into these vessels, namely the pulmonary artery, the pulmonary artery and the aorta. Okay, so these the blood flows into these great vessels from the ventricles and then goes to the respective places. So pulmonary artery, as we know, takes the oxygenated blood from the heart to the lungs, and the aorta takes the pulmonary artery takes the deoxygenated blood from the heart to the lungs, and the aorta takes the oxygenated blood from the heart to the rest of the body. So here the blood goes to the respective organs, does whatever they have to do there, what they're supposed to do there, whatever they are supposed to supply to those organs, they do that, and then they again come back to the heart via vena cava as well as the pulmonary vein. So this is basically happening here. Coming to diastole. So while when the ventricles contract, okay, that is done, okay. So once the atria contracts, it goes into diastole. Diastole means relaxation phase. Once it contracts, its job is done. It relaxes. Similarly, when ventricle systole happens, the blood goes, the ventricles also go into diastole and the ventricles relax. So, the ventricle systole happens basically lasts for 0.3 seconds, from 0.1 second to 0.4 second. That is approximately lasts for about 0.3 seconds. So in half of the cardiac cycle, most of the systole has been covered, okay, and the rest half of the cardiac cycle, both of the atria and the ventricle are in diastole, that is in relaxation phase. So this is very important, the cycle is very important, so that you can actually memorize the time period for which the systole and diastole take place. So as you can see, the atrial systole is around for 1 second, while the ventricular systole lasts for about 0.3 seconds. Now then the atrial diastole starts as soon as the atrial systole ends. So as you can see here, from 0.1 seconds to 0.8 seconds. So that means atria is relaxing around for 0.7 seconds, okay, while the ventricle starts relaxing as soon as the ventricle systole overs about at 0.4 seconds. So the ventricular diastole is basically lasting for about 0.5 seconds. So as you can see, the diastoles last longer than the systole. That is why the heart gets enough time so that the generated action potential can die out, the muscles can relax, so that they can prepare themselves for the reception of the new action potential which is generated by the SA node, the generator of the action potential, and then they can contract again and do their job again. So this is the whole cardiac cycle, and as I told you, the diastole, the relaxation of the ventricle and the atria mainly coincides. See, as you can see, for 0.4 seconds, it is basically coincide. The maximum time it is coinciding. That is why it is known as joint diastole. Because at that point of time, both the atria and the ventricles are relaxing together. Okay, so these are the timings for the whole divisions, the whole parts of the cardiac cycle. This is very important. This might be asked as an MCQ question, and this cardiac cycle can be a big paragraph, an essay type of a question. The 5 markers. This is the whole question where they can simply ask you to explain the cardiac cycle or events which are taking place in the cardiac cycle. So again, with the help of a well-labeled diagram, you are supposed to explain it, and after explaining with a diagram, you should be able to score good. So this brings me to some other concepts which are important in cardiac cycle. So that is the volume. So basically, stroke volume is a term. Now, what is stroke volume? Stroke volume is the amount of blood which is ejected by the ventricles in one ventricular systole. So stroke volume is 70 milliliter per beat. So in 1 beat, basically the blood which the ventricles by their systole manage to eject out is 70 milliliter. Now, very peculiar feature to note here is that actually about 120 milliliter comes and fills in the ventricles. However, only 70 milliliter of that is ejected out, and rest 50 milliliter is stays back, or rest 50 milliliter stays in the ventricles only. So the stroke volume is basically the amount of blood which is ejected by the ventricles, and in case of its alteration, in case of deficiencies, in case of disorders where the ventricles fail to pump out and meet the 70 milliliter of requirement, the cardiac output or the ventricular function decreases. So Now, as we all know, the cardiac cycle, basically, since it is about 0.8 seconds for one cycle, so in 1 minute the cycle completes for about 72 times. So the heart rate is about 72 beats per minute. Now, cardiac output is the amount of blood which heart manages to pump in 1 minute. That is basically nearly equivalent to the whole amount of blood which is present inside our body. That is, cardiac output is basically the amount which the heart manages to pump out in 1 minute. That is signifies the work that is done by the heart. In case the cardiac output decreases, that means the heart is not being able to meet the requirements of the body, that is, it is pumping out less blood. Now, if you calculate how much output is there of the heart in 1 minute, you can find it by multiplying the stroke volume with the heart rate. That comes out on an average nearly to 5 liters. So cardiac output is 5 liters, stroke volume is 70 milliliters per beat, and heart rate is around 72 beats per minute. So that is the end of my video. If you guys like my video, please drop a like down and subscribe to my channel and also share it with your friends. Thank you.